Okay, good morning. You're on to Mama with Jarvis, and we're going straight ahead to geometry, grade 10. I've tried to do a number of videos involving geometry, but I don't think I've done anything as it pertains to trigonometry. So we start by trying to understand what then is trigonometry. It is a study of the right angle triangle. So let's start with the right angle triangle. We cannot understand the matter of trigonometry without considering the right angle triangle. The right angle triangle creates the basic foundation for us to handle trigonometry. Now, from the right angle triangle, two important concepts come alive. We have the concept of what is called trigonometric ratios, and we have the concept of Pythagoras theorem. So those are the two important theorems you need to take note of. We have Pythagoras theorem. If you were in lower classes like grade 8, you will hear things like Pythagoras rule. And then another important concept that comes to mind here is a matter of your trigonometric ratios. I hope to do a special video on this some other time, but for today, for constraint of time, I will go straight to look at more or less special angles, trigonometric ratios of special angles. Now, to consider the trigonometric ratios of special angles, we consider two basic types of triangles. So the whole concept of your trigonometric ratios of special angles begin with the consideration of the equilateral triangle and what is called a right angle isosceles triangle. The right angle isosceles triangle will be the next type of triangle we'll consider. So these two triangles, well handled, will help us obtain all the various or the types of trigonometric ratios that we consider as special as it pertains to trigonometry. So let's look at this. The triangles we'll be considering will be something like this. Let's start with the equilateral triangle, where all the sides are equal, and then we'll cut through trying to explore one of the properties of our equilateral triangle, that if I cut through the angle, it exactly bisects the angle. Now, we assume a unitary arrangement of 2, 2, 2 round. So by that arrangement, this becomes 2, this becomes 2, this is 2, bisected becomes what? 1, 1. So the angle here is what? 60, the angle here is 60, and the angle here is 30, and the angle here is 30. Because we know that for an equilateral triangle, we expect all the angles to be equal. By the concept of splitting the diagram, I'm going to come out with this. And this becomes 2, 1. And by the help of our Pythagoras rule, this becomes what? Root 3. Remember that I said in this video, my focus is not to try to go in details to explain how these things are coming up. I'm assuming that you already have a basic idea of what we are doing, and then you're building from the basic ideas. I'll try to do other videos that will help you understand, that will build it from scratch. But today, that's not the objective. Today, we want to just have a skeleton that can help us solve practical application as it pertains to trigonometric ratios of special angles. Alright, so we have that. This becomes 30, this becomes 60, and then from this, we can now say that sine 30 will be equal to what? 1 over 2 cos 30 will be equal to root 3 over 2, and tan 30 degrees will equal to what? 1 over root 3. Thank you for that. We come to sine 60 degrees. Sine 60 will give us root 3 over 2. We expect that with time you should be able to memorize this and work effectively with them. And this will give me cos 60 being 1 over 2 and tan 60 being root 3. Okay, these are some of the angles and some of the special angles I'll be needing to handle my exercise. Now the next one I will need will be that of a right angle hypotenuse triangle. Right angle isosceles triangle. So this is equal to this, giving it that isosceles property, and this is 90 degrees. And because it's a right angle triangle, if this is 90 degrees, there can only exist one right angle isosceles triangle possibility. And that possibility is that has this as 45 degrees and this as 45 degrees. So to help us understand this better, we assume unitary properties for this and this. So this is 1, this is 1 unit, this is 1 unit, and then we have that by way of our Pythagoras theorem help, we have this to be root 2. So that set to, we will need to look for what is sine 45, what is cos 45, and what is what? Tan 45 degrees. A careful breakdown of this analysis will show you that this becomes 1 over root 2, this becomes 1 over root 2, and this becomes 1. Note of warning here. Coming into this topic, we will be using the importance of studying the special angles, understanding the ratio of the special angles is this. We want to eliminate the use of a calculator, and we want to bring alive a topic you have already been taught: use of swords. So your knowledge of swords is needed in this topic, because our final answers will be left in sword form. And an important aspect of sword you must remember here is the one we call rationalization of swords. If you have any issue with that, I've also done videos on swords. I've done videos, comprehensive videos on swords, 2 or 3 versions on swords, so you can look them up and really get yourself acquainted with what's happening there. You also notice that here I have not respected the protocol of keeping this as what? Standard sword form. So I could say that this is equal to root 2 over 2, assuming you understand why that came about, and this is because of root 2 over 2, because we said that by the concept of rationalization of sword, we expect our denominator not to be a sword. But if you don't understand this aspect, don't bother yourself. The topic is not to test how well you know your sword. The topic is just there to test, to help you remember that there's an aspect of the topic which will take you to sword, and you need some knowledge or idea of sword to be able to handle them. So with this introduction we have done, we will now try to go into solving problems. Our textbook of reference is the New General Mathematics for SS1 and grade 10, and we will be on page 146, and I'll take a different approach to the class today by only solving selected problems, looking at key ideas I will need you to hold on to. So page 146, exercise 11D, will start in a moment. Okay, we are back to our work, and we're starting with question number 16. We're starting with question number 16, and we have the question on the board. Now, we're required to look for x and y. And for some of us who have followed my previous video, now let me quickly apologize that the reason why I'm starting from question 16 is that I have a more matured audience, and we're taking this from a point where we need to break it down. So I promise I'll do other videos where I'll start from the scratch and build it to this moment. But my audience can cope, or whoever watching this video should be able to cope with the level of knowledge we're working with now. Now, we're looking for X and we're looking for Y. Alright? In trying to look for in congruency, we try to teach us the concept of splitting the diagram. Now, you can actually solve this without splitting the diagram. So I would, for this particular question, I wouldn't split out the diagram. I'll try to solve without splitting the diagram. But there are certain questions you will not be able to solve them except you piece the diagrams apart, or piece the diagram apart. So let's solve this without piecing our diagram. So the first thing you need to do is to pick the terms one at a time. So looking at the diagram, it will be easier for me to solve looking for X. Reason being this: look at X, look at 10, look at 30. When handling problem that has to do with congruency, okay, borrowing a leaf from our congruency, if you look at now this figure, in trigonometry, there are three details you must always take note of. If you say sine, for instance, you'll be working with the opposite, which is the side, and the adjacent, or rather the hypotenuse. Let's keep them in correct proportion. And then the angle. For every problem you're solving, you can only have one unknown to take care of. It's so important to check out for that. And that's the reason why we are going for X first. In this question, it might be very difficult for you to go for Y first, because look at the angle connecting this side and this side. So if I go for Y first, I'll be in trouble because I will have to take care of Y and take care of what? X. But if I go with angle 30, I can easily take care of 10 and take care of what? X. So hence my choice of going for X first. So if that is understood, you're going to have that X over 10 will be equal to sine 30 degrees. The next big question, now please, whether you write sine first, here or here, makes no difference. The most important thing is the objective, what you're looking for. So, what is sine? Sine is half. So, X will be equal to over 10, will be equal to 1 over 2. Now, remember, because I always try to connect the ideas. Every idea I've learned in maths, I always try to see if I can use one at least in a problem. You discover that the numerators can be, rather the denominators can be divided, can be cancelled out. So 2 go here 1, 2 go here 5. Now, if I have X over 5 equal to 1, this invariably means that X is equal to what? 5. That taken care of, we can now look for Y. So the big question now is, what then is Y? I will then say that X over Y will be equal to what? I'm dealing with the opposite, I'm dealing with what? Adjacent. So that will be what? Tan 60 degrees. What is tan 60? So this will now be what? X over Y equal to what? What is tan 60? X over Y is equal to what? Root 3. Is that not? What is X? X is what? 5. So I'll have 5 over Y equal to square root of what? 3. Is that not? So what then would Y be? Y will now be equal to what? 5 over root 3. Now for some of us, it might be quite difficult for us to perceive what has happened. So we may want to take it back a little. So this will be 5 equal to Y root 3. Now somebody might ask the question, why not say root 5, root 3, Y? No. we always write the rational number or the unknown or a letter before the roots. So in this arrangement, the right order is to keep y in front of the root sign. So that's the right order to take care of that. So that will be what? Y equal to what? 5 over what? Root 3. And that takes care of the problem. So y becomes what? 5 over root 3. So this is the answer for this, and this is the answer for this. If you are strong at the use of your standard form, rather your sword, you can push a little further by saying that y is equal to what? 5 over root 3 times root 3 over root 3. And that will give you 5 root 3 over 3. But that may not be necessary because that's not what we are testing in this setup. You can just leave it at this point, and that will just be okay for you at this level. Now look at the diagram we have on the board. I'm going to do something rather interesting. I'll try to solve x and y on one side so that I can have a clear perspective to what the answers will be. Now, there are a number of us that may not need to split the diagram, but whether you're splitting or not splitting the diagram, take note of this. Look at the relationship. X is related to this and it's related to this. That can work. Now, look at y. It's this, this, and what else? And this. I seen it. This, and this. So once you get x, we can find y by relating x, y, and what? 30 degrees. Are we seeing that? Are we seeing that? Now, let me show you something you have not taken note of. This is 90 degrees. Because this is 60, this is 30. When I add them together, I'm going to get what? 90. We already know that the sum of the angles of a triangle is what? 180 degrees. And for that reason, this obviously, without a doubt, must be what? 90 degrees. So that is something you, in answering this question, must figure out first. Although some students might go in a different way, they may try to get x and now get this, and then with this, now get this. You're also correct. The reason why sometimes in an exam I allow students to do what they want to do is because it's possible that even when you are taught very well, you may forget. But it's not a crime. Get the job done. It's just that you may not get it quickly done. You get it? But it will be done at the end of the day. My objective as your teacher now, taking grade 10 class, is to try to help you get these answers as quickly and as time-saving as possible. Time is of importance in modern exams. So let's continue with that. So from this, I will then say that what? X, 2 over x will now be equal to what? Cos, beautiful, 60 degrees. And then, what does that tell me here? I will say that what? X over y is equal to what? That will be tan. Look at that, 30 degrees. Beautiful. So that means that what? X, this is 1 over 2, means that 2 over x will be equal to 1 over 2. Meaning that x will now be equal to 4. Alright, that means that x will be equal to 4. So from this, I know x will be 4, and that will be 4 over y equal to tan 30 degrees will be 1 over root 3, and then y will now be equal to 4 root 3. Okay. Now we have question 18 on the board, and that's the diagram we have to attend to. Look at it. We have 5. Let's put the degree sign so we know that they are degrees. We have 5, we have x, and we have 45 degrees. So we can say that this 45 degrees is looking at this direction. So what we have left is the hypotenuse, which is facing 90 degrees, and the adjacent, which is the angle, it is where the angle is hanging on. So we'll say that 5 over x will be equal to tan 45 degrees. I hope I'm spot on there. Sine, cosine, sorry about that, that'll be cosine 45 degrees, right? The reason why I was even reading in my mind that this thing is wrong because I already have a particular expectation of what my answer should be. And at that, I'll have that what? 5 over x will be equal to 1 over what? Root 2. Which means that x invariably will be equal to 5 root 2. Okay, with that settled, what then will be y? With that settled, y will be equal to x. Because this triangle, look at it from this direction, is already another. Look at it, this is 45, this will also be 45. And this will be what? 90 degrees. So this will be equal to what? 5 root 2. And that settles that problem. Okay, here we have question 19 on the board. And we're trying to look for x and y. So let's have a quick rundown of what we need to do. This technique we're about to apply is something you're going to need when we do construction. In construction, we talk about preparing a rough sketch. In a rough sketch, it helps you mentally to perceive what your diagram would look like, and then certain area of the diagram you need to be very careful about when you handle. If you look at this, I know this, I know this, I know I'm looking for that. So these three can help us get x. Now, using the technique I'm employing, once I know this, I can look for this by relating this, this, and this. So let's use that idea and see what happens. So we look at this. What is connecting this and this? This is hypotenuse. This is opposite. Adjacent. So 3 over x will be equal to what? Cos 45 degrees. And that means 3 over x will be equal to 1 over what? Root 2. Meaning that x will be equal to what? 3 root 2. You see here that some basic knowledge you had before this class is what is playing out. It's not because of what I'm teaching. You had very good knowledge of some of these things, and it became easy for you, or it has become easy for you to understand what we were saying. Okay, having done that, we will now try to relate x, y, and 45 degrees. Now, the 45 degrees in this case is facing what? X. So we'll have that x over y is equal to sine 45 degrees. I've told my students that even if in the exam you write cos 45 degrees, I can't penalize you, because the effect, as long as it's 45 degrees, I can close my eyes, because the effect to create will still be the same. I don't want you to make that mistake, but if you make that mistake, I will close my eyes, because I have an understanding that the answers will be the same. Alright, so this will now be what? 3 root 2 over y equal to 1 over what? Root 2. So y will be equal to what? 3 root 2 times root 2. Here I need to bring to bear a knowledge you have gathered from salt, and I want to appeal, if you have any issue with salt, please go and look up my videos on salt. Now, root a times root a is equal to a. Root a times a is equal to a. So this becomes y equal to 3 times 2, and that will be what? 6. And that settles question 19. In question 20, we are told to look for x and y. I think it's deliberate by the examiner or the writer to ensure we are looking for x first. But in reality, it will not always follow like that. Exactly. It's deliberate, I think, for purpose of simplicity and trying to help us understand. The writer has asked that we should start with x, but not in every situation is x is right for us to start with x. Sometimes it will require that we do y first before we do x. Just a little observation there. Alright, so let's go ahead and solve. So we have that what? I can use this this and this. So x over root 3 is equal to tan 60. I think I'm spot on there. So x over root 3 will be equal to root 3. So x will be equal to root 3 times root 3, and that will be 3. So that takes care of x. Now let's look at y. In the case of y, it will be x over y equal to sine. Now, because I'm seeing the opposite, I know that it has to be what? Sine. So that will be sine 45 degrees. And what is x? X is what? 3. So that's 3 over y equal to, what is sine? 1 over root 2. Meaning that y will be equal to what? 3 root 2. And that solves and takes care of that. So let's go to question 21. In question number 21, our objective is x and y. So x and y. So let's start with x. X over 4 is equal to sine. Let's keep all to one corner. X over 4 is equal to sine 45 degrees, which means that x over 4 is equal to 1 over root 2, meaning that x will be equal to 4 over root 2. Now, once we've gotten x, we know that if this is 90 and 45, this will also be 145 degrees. By implication, x will now be equal to y. So which means y must be equal to 4 over root 2. Okay? Alright, we're on question 22 now. And here we are to look for x. You discover that this, and these are the terms connecting what we need to do. So we'll say 2 over x will be equal to what? Sine 45 degrees. It depends. If you say cosine, it's possible that somebody else can say cosine if he decides to take the angle, take this angle. So there's a bit of flexibility in solving problems. That's sometimes the challenge of the teacher when we are marking. We need to look at what you want to do, what your intents are. So we mark your intents, just like in the game of football. We give you a card, red or yellow, as a function of the perceived intent. So if you go with the mindset of trying to tackle somebody and in the end you're almost breaking the person's leg, it's intent. When you're in a red card, straight up, back tackle. Right, so that will give me 2 over x equal to 1 over root 2. And that invariably means that x will be equal to 2 root 2. So that's for question 22, x part of it. So when we go to y, what is connecting it? Y, x, and 60. So we have y over x, and that is what? Cosine. Up and right of that. That will be cos 60 degrees. What is y? What is x? 2 root 2. So y over 2 root 2 will be equal to 1 over 2. So at this point we cancel out, and y becomes what? Root 2 as your final answer. And that takes care of question 22. Alright, we'll try to finish up the solution to this problem. We'll be looking at this one, which will be x over 2, which will give us tan 60 degrees. And that will be x over 2 equal to root 3 over 1. And as such, x will be equal to 2 root 3. So that takes care of that one. So how do we get y? We should have y in that question. Let's just confirm where we have y stated in that question. Alright, y is stated here. So from this, we're going to have that x over y is equal to tan 30 degrees. X over y is equal to 1 over root 3. What then is y? What then is y? We know x is 2 root 2, so that's 2 root 3 rather, over y is equal to 1 over root 3. So y becomes what? 2 root 3 times root 3, which will be 2 times 3, and that is what? 6. So the solution to that problem becomes what? 6. Okay, we go to question 24. In question 24,